alpha and beta are the roots of x square minus kx plus 6 is equal to 0, and they are in the ratio 2:3. What can the equation which has alpha plus 2 and beta plus 2 roots be? So if the roots are in the ratio 2:3, let us assume that both the roots are of the form 2p and 3p for some number p. We know that the product of the roots of the given quadratic equation is equal to 6, because we know that in a quadratic equation which is of the form ax square plus bx plus c is equal to 0, the sum of the roots will be minus b by a, and the product of the roots will be equal to c by a. So in this particular case, the product of the roots is equal to 6 divided by the coefficient of x square, which is 1. So the product of the roots is 6. So 2p into 3p is equal to 6, or p square is equal to 1, which would imply that either p is equal to 1 or p is equal to minus 1. If p is equal to 1, the two roots will be 2 and 3. If p is equal to minus 1, the two roots will be minus 2 and minus 3. These are the values of alpha and beta. We are required to find out the values of alpha plus 2 and beta plus 2 first. So alpha plus 2 and beta plus 2 will be either 4 and 5, or there will be 0 and minus 1. What will the roots of the first equation be? The roots of the first equation will be, the quadratic equation will be x minus 4 into x minus 5 is equal to 0. And the quadratic equation which has the roots as 0 and 1 will be x into x minus of minus 1, so x plus 1 is equal to 0. If you expand both of them, the quadratic equation is either x square minus 9x plus 20 is equal to 0, or it is equal to x square plus x is equal to 0. Any one of the two is possible. If you notice, option C is the correct answer. The other options look similar to the first one, but they are not the same. The signs of 9x and 20 are different. So none of the remaining three quadratic equations are correct. The only equation which is correct is option C.